In order to multiply radicals and divide radicals and to rationalize the denominator, which is a simplifying rule, there's certain steps to follow and certain things to look for. We'll multiply first. When you multiply radicals, you need to know that our overall plan is to multiply the outside times the outside and the inside times the inside. So first, we'll factor the radicand. Oops. Or all the radicands, if you can. And then we'll multiply. And by that, I mean multiply the outside times the outside and the inside times the inside. And then you simplify your radicals. With this first example, we will factor 22. 22 is 11 times 2. And then we'll multiply. We multiply the outside. There's a 1 here. So 1 times 3. And multiply the inside, and they are still in the radical. 11, square root 11 times 2. These are both square roots. I have two 11s, so I can pull one out and simplify, and that will leave me square root 2. When I rewrite this, I have 3 times 11, square root 2, which is 33 square root 2. And you can check yourself on a calculator and make sure that the initial expression and the simplified answer are equivalent. Here I have another example. We'll simplify first. 27 is 3 times 9. 9 is 3 times 3. It's also a perfect cube, 3 times 3 times 3. 15 is 3 times 5. We'll multiply. So I have 2 times 6 outside, and inside I have 3 times 3 times 3 times 3 times 5. Since I have square roots, I need groups of 2 to simplify, so I found 2 pairs and take 2 3s out. So now I have 2 times 6 times 3 times 3, square root 5. And when you multiply all these numbers together outside, this is 108 square root 5. This last example, negative 5 square root 18 times 3 square root 12. I can factor these first. 18 is 2 times 9. 9 is 3 times 3. 12 is 2 times 6. 6 is 2 times 3. So I have negative 5 times 3. These are my outside numbers. And in the radical, both are square roots. I have 2 times 3 times 3 times 2 times 2 times 3. And I need pairs to simplify a square root. The 2 and the 3 don't have a mate, so I'll write this as negative 5 times 3 times 3 for this first group times 2 for my second group. And inside the radical, I have 2 times 3, When I multiply the numbers together outside, I get negative 90, and inside I get square root 6. We'll also divide radicals. And dividing has a different process, obviously. So here I have, when you're dividing radicals, make a note that you can rewrite the radical with both the numerator and the denominator inside. That's as long as the index matches. So first, we'll rewrite as a single radical. And second, we'll simplify the radical. And then we will simplify the fraction if there is, simplify further. If possible. Okay, let's rewrite as one radical. All right, here we go. My first example is square root 6 over square root 3. I can write that as one radical, square root 6 over 3. I can reduce this. 6 divided by 3 is 2. So this is, if I divide numerator and denominator by 3, I get 2 over 1, which is square root 2. That's all. I didn't end up with a fraction, actually. Next, I have 3 times cube root 2 divided by cube root negative 54. These radicands match, so I can write this as 3 times cube root 2 divided by negative 54. 54, I can reduce this if I divide the numerator and the denominator by 2. Then I could write my problem as 3 cube root 1 over negative 27. 27 is a perfect cube. One over 3 times 3 times 3. It's maybe helpful to think of this as 3 fractions here that match. So I have a group of 3 factors, and I need 3 to make a group. So I can write this as, oh, these are negative. Whoops. Yeah, negative. 3 times 1 over negative 3. When I multiply those together, I get negative 1. This last example, 7 square root 180 divided by square root 10. This is 7 times square root 180 divided by 10. So when you divide by 10, you just take the 0 off. This can be written as 7 square root 18. I divide this by 10, and I divide this by 10. 18 can be factored as 2 times 9. 9 is 3 times 3. So I can simplify this radical by taking a 3 out, and this 2 will stay inside. So now I write my expression as 7 times 3, that's this 3 that was inside, and square root 2. 21 square root 2. One other rule when you're simplifying or when you're multiplying and dividing, and it is a rule for simplifying radicals, but we haven't needed to use this yet, is that you have to rationalize the denominator. What that means is simplified radical, it can't stay in the denominator. So first, we'll multiply both the numerator and the denominator by that radical. And I mean the radical in the denominator. And then you simplify if possible. So here I have a few examples. First, 1 divided by square root 2. This is a simplified radical, but it's against the rules to leave it in the denominator. So I will multiply by the denominator, which is square root 2 over square root 2. This is just a really specific way to write 1. Oops. Goodness. Specific way to write 1. So you're always allowed to multiply by 1. That's why we can do it like this. I have 1 times square root of 2. When you multiply fractions, you multiply numerator times numerator, denominator times denominator. I have square root 2 over square root 2 times square root 2. That's square root 2 squared. When you have square root and squared, those are inverse operations. So this is square root 2 over 2. That's simplified. I no longer have a radical in the denominator. X, 6 divided by square root 3. I multiply by 1, which is, I'm going to write 1 as square root 3 over 3. 6 times square root 3 is the numerator. The denominator is square root 3 times square root 3. Square root squared, this will just be 3. Our last step is simplify if possible. And I can simplify this. If I divide the numerator, the whole number, by 3, the integer, and I also divide this denominator by 3, then this can be written as 2 square root of 3 over 1, which is 2 square root 3. It's no longer a fraction at all. I have one more example here. This one, I'll multiply the numerator and the denominator by square root 2. My numerator, I'm multiplying radicals together. The denominator no longer will have a radical, it will just be 2. So I have 4 over 2 square root 6 times square root 2. This can be reduced. Divide by 2, divide by 2. The 6 and the 2, I'm going to break this down as 3 times 2. And then I'll write it as 1 radical with everything joined together. So when I reduce this, I have 2 square root 3 times 2 times 2. So I have a group of 2's. The 3 stays in. So I have 2 times 2 square root of 3. This is 4 square root 3. All right, please do your practice.